Okay, strap yourselves in because today we're going deep on rocket science.
Whoa.
And get this, the fuel for our deep dive is a collection of educational resources
Yeah.
from Singapore.
Pretty cool, huh?
Right. Who knew you could find so much about rocket physics in one place, like interactive simulations, coding lessons,
Oh, wow.
even videos of student-built satellites.
Oh, yeah. It's amazing what they've put together. It really shows you how you don't need, like, $1 billion space program to learn the basics of
rocketry.
rocket science.
Yeah, they break down some pretty complex ideas into
Yeah.
digestible and fun learning experiences.
Yeah, they're very hands-on, very interactive.
Yeah.
So speaking of hands-on, let's kick things off with this.
Okay.
Rocket JavaScript HTML5 Applet simulation model.
Catchy title.
Right. Now I know the name sounds a little technical.
Yeah, like it came straight out of the tech manual.
Right.
But trust me.
But it's really cool.
Actually pretty cool.
It is, yeah.
Because it's this interactive simulation.
Mm-hmm.
It's like a...
kind of like a digital sandbox.
Yeah, where you can just play around with the physics of launching a rocket.
Yeah, and what's neat is that it's not just a, like, just watch it happen kind of simulation.
Right. Pre-packaged.
It's an incomplete template that's designed to be a starting point for a project about modeling rocket launches.
Interesting.
So you can get in there and really get your hands dirty with the code.
So you're actually...
And they even give you the code.
You can, like, tweak the code.
To embed it on your own web page.
Wow.
Using something called an iframe.
Okay, so...
Have you ever heard of an iframe?
I've heard of it.
Have you ever used one?
I don't think I've used one.
Okay.
But I'm picturing like a...
Yeah, I know. It sounds kind of like...
a digital picture frame.
Like a digital picture frame.
But I feel like that's...
It's not quite that.
Not quite it.
It's not quite that.
Yeah.
So basically an iframe is a way to display content from another website within your own website.
Okay.
Like you can...
Like a little window.
Yeah. Almost,
another site.
Almost like a window to another site.
So they're giving you the code to make a little window.
Yeah, exactly.
That shows the rocket launch simulation.
Yeah, so you could put this right on your blog or your website or whatever.
Yeah, that's really neat.
And
so you learn by doing.
Leaving it incomplete.
Yeah.
It really forces the user to kind of finish it themselves.
Instead of just passively observing.
Yeah.
Tinkering.
It's a great way to learn by doing.
Yeah. Really getting in there.
Yeah.
Yeah.
So for those who might need a little guidance with the coding side of things, the web page also provides a link to a lesson on coding rocket physics.
Okay.
And it covers everything from calculating thrust and simulating gravity to factoring in the effects of air resistance.
So you could build your own, like a full-on...
Yeah, you could literally build your own...
rocket launch simulator.
Rocket launch simulator, yeah.
That's really cool.
Even if you're...
Yeah, even if coding isn't your thing, this resource...
Yeah.
Seems like it breaks it down.
It breaks it down in a way that's accessible.
In a way that's approachable, yeah.
Yeah.
Okay, but speaking of turning knowledge into action...
Okay.
This web page also features something truly inspiring.
Oh, cool.
A video showcasing the launch of Singapore's first student-built satellite.
Cool.
By a team from...
So this isn't just theoretical stuff. This is...
in Anyang Technological University.
This is happening in the real world.
Yeah.
It's really exciting.
Like, this is not just theory.
Yeah.
It's
really...
Like, this is real.
Yeah.
Which is amazing.
It's a great example of what's possible when you bridge that gap between theoretical learning and practical application.
Yeah.
Like, this satellite wasn't just a fun project, you know?
Right.
It was designed to conduct real scientific experiments, capture images of Earth,
amazing,
gather valuable data.
Yeah, it's like that makes you want to grab a textbook and like a soldering iron and just start building.
I know, it's so motivating.
Right.
It's really inspiring.
Yeah. Okay, but let's shift gears for a sec and talk about a different kind of rocket.
Okay.
One that you might even be able to build at home.
Oh, cool.
A model rocket or something?
Well, even simpler than that.
All right.
The web page links to this video demonstrating this classic physics experiment.
Okay.
The water rocket.
Ah, yes, the water rocket.
You remember those?
Of course. Classic.
It's
a great way to illustrate Newton's third law of motion.
Yeah, right.
In action.
You know, you see a rocket blasting off into space.
Yeah.
And it's like, how...
You think like magic?
It's like magic.
How can something so heavy just defy gravity?
Right.
But it all comes down to basic physics.
Right.
And this simple experiment with the water-filled bottle shows you the basic principle behind it.
Oh, so...
Have you ever done the water rocket experiment
I have. I've done it as a kid.
Okay.
But I feel like I never fully understood.
Yeah, it's one of those things you kind of do.
Yeah.
And you're like, wow, that's cool.
Yeah. How does that work?
But you don't always understand what's going on.
Yeah.
It's all about pressurized air
Okay.
and action-reaction.
Got it.
So you partially fill a bottle with water.
Okay.
And then you use a pump to pressurize the air inside. And when you release the pressure, the water shoots out the bottom.
Right.
And propels the bottle upwards.
Yeah.
It's a really vivid demonstration of Newton's third law.
Okay.
For every action.
Oh, so that's how...
There's an equal and opposite reaction.
That's how it's demonstrating it.
Yeah, the force of the water pushing down on the air creates an equal force.
Yeah. Right.
Pushing the rocket up.
Got it.
Yeah. So it's amazing to think that the same principle
It's incredible.
that launches this little water bottle is also at work when you have a massive rocket
it's just
lifting off from Earth.
a much grander scale.
Yeah, much grander scale.
It's the same.
But it's the same physics.
Yeah.
It's really cool.
And it shows that learning about rocket science doesn't have to be intimidating or require all this fancy equipment.
Sometimes the most basic experiments can reveal profound scientific truths.
Yeah, for sure.
That's what I love about science.
Yeah.
You can learn so much from
just the simple things.
simple everyday stats.
No, totally. And it really shows you how accessible learning can be. Which brings us to another really cool thing about these resources.
Yeah.
They're part of this open educational resources, open source physics at Singapore initiative.
It's a mouthful.
Yeah,
But it's a great initiative. Yeah, it's kind of baked into the name. But what does that actually mean?
So basically it means that they're embracing the idea of open educational resources, or OERs, as they're often called.
OERs, okay.
Yeah, and these are materials that are free
Okay.
for anyone to use, adapt, and share.
Wow.
Regardless of where you are or what your background is.
So we're talking like textbooks, lesson plans, simulations.
Yeah.
Videos like the ones we've been talking about.
Exactly. All freely available.
That's incredible.
It is pretty incredible.
It seems almost revolutionary.
Yeah.
In a world where like educational resources are often
you said it.
locked behind paywalls.
Paywalls or restricted access. Yeah.
Yeah. It's like imagine a world where a student in a rural village has the same access to high-quality physics simulations
Wow.
as a student at like a prestigious university.
Yeah.
That's the potential of OERs.
Yeah. That's really amazing.
To democratize learning.
Yeah.
Make knowledge truly accessible.
Yeah.
And it's not even just about
Yeah.
passive consumption of information.
Right. Right.
Right. Like we saw with that rocket simulation.
Yeah. Exactly. It encourages active learning,
Yeah.
experimentation.
You're not just reading about rocket science.
Yeah. You're getting your hands dirty.
You're getting your hands dirty.
Playing with the code.
You're like really grappling with it.
Yeah. Really grappling with the concepts.
And that's where like real understanding happens.
Exactly. That's where the real learning happens.
And then the beauty of OERs is that it's like a collaborative approach.
It is. It's very collaborative.
You can adapt existing materials.
Yeah.
Create your own.
Share them with others.
Share them with others, yeah.
Contribute to this ever-growing pool of knowledge.
It's almost like a global classroom.
It is. It's like a global classroom.
Where everyone's a student and a teacher.
Exactly.
And it's like all learning from each other.
I love that idea.
What I find so fascinating is that like something as simple as a web page can spark this chain reaction of learning
it's true.
and exploration.
Yeah. And it really underscores the importance of initiatives like open source physics at Singapore.
Yeah.
They're proving that high quality educational resources don't have to be exclusive or expensive.
Right.
They can be accessible to anyone with an internet connection.
It's amazing.
Which is amazing.
Like, it really makes you wonder about the potential ripple effects.
It does, yeah.
Like, maybe someone stumbles on this web page, gets inspired.
Totally.
And ends up designing the next generation of spacecraft.
It could happen.
That's amazing. Yeah, it's pretty mind-blowing, isn't it?
It is.
Like, all this knowledge just out there.
Yeah.
Free for anyone who wants to learn.
I know.
But we've covered a lot in this deep dive.
Ever.
From those interactive simulations to student-built satellites, even the water rocket.
Yeah, the classics.
What stood out to you most?
Oh, that's a tough one.
Yeah.
You know, I think what I find so inspiring is the power of these resources to really spark curiosity and inspire, you know, that next generation of scientists and engineers and
the
explorers. Yeah, like someone somewhere might be encountering these concepts for the very first time
right.
through these open educational resources.
It's amazing.
And it's just a reminder that education doesn't have to be confined to,
right.
classrooms or textbooks. It can happen anywhere at any time.
Yeah.
Thanks to the internet.
Right.
And the generosity of those who share their knowledge freely.
Absolutely. And it all comes back to that idea of democratizing knowledge, right? Making sure everyone has the opportunity to learn, to explore, regardless of where they come from or their background, their circumstances.
Yeah, it's really powerful.
It is.
And it gets you thinking about how we can all
contribute to making education more accessible, more engaging.
For sure, whether it's creating your own OERs or sharing existing ones with your network or just advocating for open access.
Yeah.
There's so many ways to be a part of this movement.
Well, on that inspiring note, I think it's time to wrap up our rocket science deep dive.
Time to come back down to Earth.
Right.
Yeah.
From orbit.
We've explored quite a bit today.
Yeah, we really have.
But as with any journey into the world of science, this is just the beginning.
It's true. It's just the beginning.
Yeah.
And before we sign off, I have one final question for you.
Okay, shoot.
To ponder.
Right.
If you were to design your own rocket simulation, what would be the one crucial element you wouldn't want to leave out?
That's a good question.
What would you be most excited to learn or explore?
What would I be most excited to?
Yeah.
To learn or explore, that's a tough one.
Yeah, let us know.
Yeah, let us know.
Because we'd love to hear your thoughts.
We would.
So until next time.
Yeah.
Keep exploring.
Keep learning.
Keep learning.
And keep those questions coming.
And keep those questions coming. Who knows what amazing discoveries await?
Exactly.
In the vast universe of knowledge.
That's right.
All right. Thanks for joining us.
Thanks for having me.